Okay, we're closing the doors. We're about to get started. Thank you, everyone, for joining us at 4 p.m. on day one. The room is almost full. I don't think it's half full, but it's great. Thank you. We're going to talk about Azure Confidential Computing. So the objective of this session is to educate everyone a bit about the Confidential Computing initiative and go a bit deep. So we'll have a few demos, and we'll go a bit deep on the technical side of confidential computing. And I would like to organize the session that way. We'll have a few slides to take you through presentation. We'll cover some demos, and I think we'll do a bunch of Q&A, a lot of Q&A at the end. My name is Christophe Herbach, and I'm with the Azure Compute team based in Redmond. And with me today, Jakob. And Jakob is one of our SQL experts, so Jakob will cover a SQL always encrypted demo. And later, Michael Glaros will join us to cover another demo on the blockchain and the what we call confidential consortium blockchain. The challenge is Michael is also giving another presentation at the same time. And we run and we walk a lot here, right? So I think his session is actually kind of the other side of the convention hall. So he's going to be running fast. So hopefully he makes it on time. And we'll need to give him a break if he's panting for half of his demo. I'll grab this and get us started. So when it comes to data security in the cloud, right? I'm like data and code, and I'll talk about data and code specifically today. I think the cloud is pretty safe and pretty secure. It's more secure than most on-premise platforms. It's still a big concern for everyone, right? It's still a big challenge. What happens to the data? What happens to the code when it's in the cloud? Who has access to this? And confidential computing is this initiative that we form to address these big issues. Right? I think number one issue is, what if someone who's not supposed to have administrative privilege to your data or access to your code gets this access and does something with that data and that code that he was not supposed to do with? Right? Second scenario are people hacking. And today, because we encrypt the data in storage, most of the hacking happens when the data and the code is brought to memory, and people snoop that data at that time, and that's what makes this data vulnerable. Right? The third big threat or concern is these third-party accessing data without your consent. Right? And we'll try to talk about these three today in the presentation. What Azure Confidential Computing is, it's all about how do we guarantee that the data is safe and you have control with this data wherever it is, whatever happens to this data in the cloud. So you're familiar with encryption at rest in storage. Your data is in Azure. It's encrypted in Azure. It's true for most data that's in Azure today, right? The data is also encrypted in transit as it moves either through Azure properties or from your on-premise data center into Azure, right? And there's multiple ways today to protect that data in transit. What do we do to protect data as it's being used by the applications that you run in the cloud? And this is what confidential computing is about, is bringing this new, how do we encrypt data in use, so the data is always encrypted, whether it's at rest, in transit, whether it's being pulled and used by an application, that data is encrypted at all times. And there's two ways today, two technology ways, to protect data and encrypt data in use. It's the technology we're going to be talking today about, this trusted encryption using technologies like Intel SGX, or homomorphic encryption, and I won't be talking about homomorphic encryption today. Just so you know, guys, this exists as well. Right? So our vision for a confidential cloud is really there, right? Is we want to have a cloud. We want you to consider Azure as a platform where the data you run in the platform, the code you run in the platform is opaque to the platform, right? And if that really, you should not be considering whether Azure can see the data, Azure can process the code, Azure can do something with the code. You should have all of that in your control. My voice sounds very robotic. Sorry, guys. Like with the, is that okay with you? Can you hear me well? Okay, for me, like it sounds super robotic, so apologize for that. But really, is how do we give you full control of this data, and so that you consider the platform as just a platform where you're going to run stuff, right? So today, the presentation, we're going to pivot the presentation across these six axes. I don't refer to confidential computing as a product. It's not really a product. It's a series of hardware implementations, some software implementations, and attestation, right? So from a hardware perspective, it's what are the technology, what is the hardware technology we use to enable the capability to encrypt data in use, right? From a software perspective, how do we serve that capability to you in a way you consume already Azure today, right? Through virtual machines, through services. And attestation is super important because attestation is the service that we run on top of this. So if you're familiar, if you're running security systems in your own on-premise data center today, you probably run your own attestation program, right? All the logs, how services, our applications are accessing the data, where you capture that log, is there a process that reviews this log and give you alerts, give you control, give you, hey, this is what's happening to my data, as my data being tampered by someone, as my data being accessed by someone, and how can we build a process and a service to you as users of that service in Azure that includes that Microsoft run, Azure run attestation. Right? And when you combine all of that together, hardware, attestation, and compute, then you have what we call that Azure Confidential Computing initiative. Right? We'll be talking with Jacob. We'll be talking as well about what are the use cases, what are the development experience, and how we keep partnering with Intel, with ARM, but with also Microsoft Research to just continue building that capability to improve the program. So what would you need confidential computing for, right? There's a bunch of use cases. A lot of them are very specific to your businesses and the way you operate your platform today. Protect data is pretty obvious, right? There's data that is private to you, your customers. You want to protect that data, whether your applications are on site or whether you are accessing a remote location. And how do you ensure that data is safe? That could be applicable to code as well. If you are a business that has, let's say, a specific secret in the way you do things, right? Whether it's an algorithm that uses your proprietary information, like some standards of how you operate the data, right? Not only the data itself, but the code you're going to run on that data. You want that code, that algorithm, to be untampered, right? You want that code not to be accessible by anyone who wouldn't have the right to see the code. Right? There's a trusted network of nodes among a set of untrusted parties, or how to centrally combine different data sources for better algorithmic. What we can do with confidential computing, we can use this trusted environment so that different parties can bring their data or can bring their code, share information together without any of these parties being able to access code or data that is being brought by another party, right? So an example here would be, like we have some customers like big hospitals, right? They want to put patient data together so that they can build some intelligence on how should they improve their system, should they improve their care. But that data is very confidential, right? So as they bring data so that they can build an algorithm and understand what trend they can see in this data, they don't want other hospitals who could contribute to the initiative to see that patient data, right? So they're all bringing data together. They execute the algorithm on that pool in a trusted enclave, but then the data is not accessible by any other party than them, right? Do I miss one, Jakob? You think you're good? Yeah, keep me honest. Right, so let's dive in. I'll start with hardware. Our service, Azure Confidential Computing, today runs on what we call a trusted environment, or an enclave. It's basically on the chipset, a portion of memory and CPU that is being reserved for executing these confidential computing operations. Right? It's sealed, which means that once you have code and data within the enclave, it's not accessible by anything outside of the enclave that doesn't have rights and authorization to access that code. Right? So here we're not talking about a software solution to encrypt data. It's a hardware-based solution. Right? And that create, like today, most applications that would run data or code on the CPU, that's when your security is at risk, when that data is brought to memory, and that's where people can snoop it. And that's what the enclave is preventing to do, right? So anyone who will not have access to that portion of access within the enclave could not see anything that's happening in the enclave. We run this on a technology from Intel. So Intel has specific chips called Intel SGX, where we reserve a portion of the hardware or portion of the app that brings code and data together, and we build that physical hardware-based enclave that secures operations within the enclave, right? So think of this as a black box, and no one who doesn't have the keys to the black box can access and see what's happening in the black box, right? So your code, your algorithm runs in the black box, but everything that happens outside of the black box, it's blind to this process. Right? This is just to compare a bit the different kind of hardware that is providing security today, right? So it's very different than TPMs or HSMs. TPMs are usually like, it's a separate chip on the motherboard, so you have this on your laptops today, that like if you have BitLocker on your laptop, that uses the TPM chipset as a hardware-based encryption technology. HSM, so we do HSM in Azure. It's like Azure Key Vault, for example, where you store your keys on an HSM server, which is going to like prevent people from accessing these encryption keys on the hardware. It's different than that. We're really talking here about an enclave, a T, that is a secure container in which you can run your code. The beauty of this, the benefit of this, is we can run attestation. We run attestation as a service as part of Azure Confidential Computing. So all of the attestation of what's happening in the enclave is part of being able to use the enclave and the service in Azure. And we also seal the enclave, which is Microsoft guarantees that once you have put your code and your data in the enclave, then it's sealed. And under the conditions you specify, no one can just breach through that enclave and look at it, right? And if you think of this, we offer this as in Azure as a service, but you could think also that Microsoft could look at providing this. All of these could be different services, right? So you could decide to say, hey, Microsoft, I want you to seal an enclave for me, but I don't want that enclave in Azure. I want that enclave to run on a specific location, maybe in a car or maybe anywhere. And you can run also attestation as a service to say, hey, I like Microsoft attestation. I have my own attestation. Can I combine them together? Yes. But these are modules of how we are putting this software together. SQL Always Encrypted is a great example of how Microsoft's own product are using this ACC feature capability, right, to better and add capability to our platform. So exactly what Jacob is going to talk about later today. Okay, moving on, compute. I think that's the big thing we wanted to cover with you today. From a compute perspective, we're guiding all of our hardware partners to include an ACC, an enclave offer in their buildup, right? So today we partner up with Intel, and most of the offer is built on Intel SGX, but we're going to be partnering with other silicon providers. The offer we're launching in the next few days is built on the latest Intel Xeon processor that has Intel SGX. And what's really cool is Intel has made this processor available for Azure before it's available outside of Azure. So if you're a user of Intel SGX today, Intel SGX in Azure is the latest technology from Intel that you won't be able to find outside of Azure for a little while. Right? This service is available as a virtual machine. So exactly as you consume virtual machines today from Azure, we're creating a new virtual machine. We're calling it DC series. And the DC series VMs are going to have the confidential computing enclave enabled. They're going to run on this new hardware. They're going to have the ACC technology enabled. And it says early October. Actually, it's as early as the 1st of October. So on the 1st of October, you'll be able to go and access these VMs in a public preview way, right? So the big difference between GA and public preview is this is going to be available to everyone on October 1st. We don't have a full-blown SLA yet on the service, right? So you'll be able to test it, use it, and the SLA is going to come as we go GA with this product. I don't know what you mean by working on support with other managed compute, so I'll skip on that. But that's the big thing, right? Is like, think of this as a VM. You access the VM, and the VM works on the Intel XJX built hardware, and you have this service accessible as easily as you access other VMs in Azure today. So I'll talk a bit about the software-based portion of this, right? When you think of an application that is going to use confidential computing, think of the host package and the enclave package of the application, right? The host contains the portion of the application that can run untrusted, right? So you don't need necessarily to secure the portion of that code or that application. And what needs to run in the enclave is, of course, what is your secret sauce or private algorithm or the data you absolutely want to make sure is untampered, right? And building an application for ACC is always going to have you consider these two things, right? Which part of the code do I need to run on the host? Which part of the code do I need to run in the enclave? And it's an optimization thing. The more code you run in the enclave, the slower the execution of that code. And of course, if you run everything on the hosted part of the application, then it's not secured, right? So think of this as it's like a user mode, kernel mode kind of like dialogue between what's going to be in the host, what's going to be in the enclave, and how that application needs to be built so that these two parties talk to each other. What this means is likely the applications you have today that you want to secure will have to be refactored to be able to leverage that technology. Right? So if the application doesn't call specifically for code that is in the enclave and waits for like in and out instructions from the enclave, then the application wouldn't use the technology, wouldn't use the part of ACC that makes it so secure. Right? So I don't want to like oversell this. Right? I'm not saying it's going to be as easy to move an application in Azure and have it benefit from that. You won't need to rebuild the whole application, but the application, some parts of the application will need to be refactored so that you understand exactly what is it you really need to put in the enclave and how do you need to call in and out data and code outside of that enclave, well, into and out of the enclave. We are also launching, so not on October 1st, I think we're launching this like October 8th or 10th, so a big week after the VM is available. We're going to launch our Open Enclave SDK just to help you build applications and services on the confidential computing platform. I'll talk about exactly what's in the SDK. This SDK supports Windows-based operating system, Linux-based operating system. We have, well, the SDK is going to be built around Intel SGX, but soon we'll have a ARM Trust Zone support as well as part of the SDK. It's going to be standardized, pluggable, so you can use ACC on a multi-platform way, right? Whether it's going to be Windows and Linux to start with, right? But it's still multi-platform in that sense. And it's going to support, in terms of runtime, it's going to support C and C++, right? So we'll consider, and we're working actually on adding other runtimes to confidential computing. But right now, the code that you're going to be using in the enclave, that runs in the enclave, needs to be in C and C++. In terms of crypto library, we're going to be using the embed TLS later in October. So probably not exactly when the SDK is going to get out, but like a couple weeks after. Right, so this SDK is going to let everyone using the SDK do enclave creation, enclave management, measurement of what's happening in the enclave, how to read and how to process the attestation of the code running in the enclave, all the mechanisms to call in and out data, and what you need to build and like guiding you on how to craft this application, and how to think and strategize what needs to be on the host, what needs to be in the enclave, and the cryptography library as well. Do I forget anything? I think not. So that slide is a repeat, actually. To close on the enclave, right? We have a SDK available October 8th. We are supporting all of this. Linux as an operating system. Actually, all of our customers who run ACC today, a good like 70% of them are running Linux code on our ACC enclaves, right? So while we love our customers to use Windows, we're totally agnostic here in terms of what is the operating system that you want to run in the enclave. We support both Linux and Windows completely equally. C++ as a runtime, I talked about that. And today, the SDK is only built for Intel SGX, right? But we'll have ARM Trust Zone coming soon. So in terms of scenarios, I think we prepared a few demos. Hopefully Michael can join us. But Jakob, do you want to go over and get started on your SQL presentation? Sure, so we had you go after Michael. So I'm going to skip a few slides and make sure that we get to your slides. And I'll give you the clicker.
All right.
Thank you.
Can everybody hear me? Okay, perfect. So I'm Jakub Przemaszek. I'm part from the database group. I work on SQL Server and Azure SQL Database. I've built a bunch of security features. And currently, the thing that I'm working on is called Always Encrypted. So Christoph talked about all this work we are doing on one side to enable you to benefit from the innovation that TEAS, Trusted Execution Environments, and enclaves provide, so that you can build your own application that benefit from these technologies. So that's one way you can actually consume confidential computing capabilities. The other trend that you're gonna see in Azure and the Microsoft in general, you're gonna see more and more Microsoft services and products that use enclaves internally to provide the same benefits to you directly, basically protection of sensitive data in use. So that's what I'm going to talk about is an example of that. So I'm going to talk about how we leverage enclaves and TEAS to bring confidential computing capabilities to SQL customers, to customers of SQL Server and Azure SQL Database. Okay. So first, let me first try to map this concept of confidential computing to the world of relational databases. Okay. So in database systems, by confidential computing, we mean a set of capabilities that aim at protecting sensitive data from high privileged but unauthorized users, right? And that means database administrators of machines hosting your data. That includes cloud admins, cloud operators. That includes any software, any potentially malicious software that can be running on a machine hosting your data, right? So the goal is to protect the data that is being used during processing of SQL queries inside the database environment, right? So that's the security objective. Now, the key other goal is to achieve that first objective in such a way that doesn't compromise the processing capabilities of the database systems, right? So what we want to achieve here is that we want to, on one side, protect the data from these powerful adversaries that I mentioned, and on the other hand, we want to ensure that the database system, that the database can continue reason about the data, that can continue perform computations on the data, right? So these are quite two conflicting goals, right? And until recently, these goals were mutually exclusive. So you could have one, but not the other. So that's a big problem that we are trying to solve in the SQL team, how to protect data in use and also preserve database system, SQL Server engine capability to reason about the data, to perform queries on the data that is never exposed in plain text to admins, right? So I'll tell you what we have done so far on this journey, right, towards confidential computing in SQL. So about 2 years ago, we did the first step towards the vision by shipping the feature called Always Encrypted in SQL Server 2016, and it's available, has been available, generally available in an Azure SQL database for about 2 years as well. So it's a client-side encryption technology. So what this means, data is encrypted and decrypted on the client side using keys that are never ever exposed to the database system, to the server side, right? So what this means is that the SQL Server engine never sees the data in plain text, right? And this client-side encryption also has two other important properties. One is the transparency of cryptographic operations to your application. So your application doesn't have to know what algorithms are used for data encryption, which data is encrypted, which isn't. All that is figured out automatically by a client driver, which is part of the client application, such as .NET Framework, ADO.NET, .NET Framework, or ODBC or JDBC, right? So that's one important property. And the client driver transparently encrypts anything that leaves the client trust boundary and is sent to the database system, and then it transparently decrypts any query results that are retrieved from the database are encrypted, right? So that's one important characteristic. The second important characteristic of this current version of Always Encrypted is that it provides basic confidential computing capabilities. Christoph mentioned that one way to achieve confidential computing is by using homomorphic encryption. So this is kind of what we did in this first version. We namely employed what we call deterministic encryption. So it's not exactly homomorphic encryption. This is type of encryption that belongs to the property encryption algorithm category. What it does, it always produces the same ciphertext for a given plaintext value. So you can call it n times, and it always give you the same ciphertext for a given plaintext. So what it allows us to do, it enables SQL Server to conclude that two plaintext values are equal or not without seeing them, right? By just comparing the ciphertext. So in the world of relation databases, that allows you to support queries like point lookup searches, right? Or equality joins, or simple aggregations using group by operations, right? So you can do that in a confidential way, and that's what we did in this first version of Always Encrypted. But of course, equality comparison is not sufficient for many applications. If you have an application that processes a broad set of personally identifiable information, such as names, addresses, phone numbers, and so on, right? You likely need more than just equality comparison. You would like to do pattern matching or sorting or maybe arithmetical operations on some numerical sensitive data, right? So that is not possible in the current version that is publicly or has been generally available for quite some time. The other problem that exists today that customers using this current version of Always Encrypted have is well, SQL Server doesn't have access to the keys. That's kind of the principle of our current design, right? So that means that SQL Server cannot perform any cryptographic operations on the data at all, right? Which means that if you need to encrypt your data for the first time, or if you need to re-encrypt it later on to rotate encryption keys, right? You need to move all the data outside of the database, perform this desired cryptographic operation outside of the database, and upload your data back, right? So you can imagine that doesn't scale very well, and it's prone to network errors, and also it causes all kinds of security and compliance problems, because now this place that you're moving the data to needs to be a part of your compliance boundary, and so on, right? So not a great story. So we are going to solve these two problems by leveraging keys or enclaves Christoph talked about, right? So the way we're going to do that, we morph SQL Server into an enclave application. So SQL Server now can, when it starts, it will initialize an enclave. It will contain an enclave, right? And this enclave will act as an extension of the client-side trust boundary, right? So, you know, in the Always Encrypted kind of a thread model, the client is trusted and SQL Server is untrusted, right? That's the assumption. So now, on the server side, we have this enclave that acts as an extension of the client. It's like an agent behind enemy lines, right? Or like a foreign office, an embassy in a country, right? So the way we're going to use this enclave, SQL Server will basically delegate certain computations on the data to the enclave, right? And remember, the data is stored in the encrypted form, and that's what SQL Server, the untrusted part of it at least, can access. So now it will send this encrypted data to the enclave, and the enclave being a trusted execution environment, right? It can now safely decrypt the data, and having access to plain text, it can do whatever it wants, right? Sky is the limit. It can perform, in general, arbitrary computations on the data having access to plain text. However, we are starting with what our customers ask most frequently for, pattern matching, range queries, these kind of things, right? And also, we want to enable what we call in-place encryption. So now, having this trusted entity on the server side, we can leverage that fact also to support cryptographic operations without moving data outside of the database, right? So you get this, the feature will become more useful and more scalable, especially in conjunction with large data sets, right? So let me actually show you how this works using a simple demo. Let me make sure we are connected here. All right, you can see it, perfect. So for my demo, I'm going to use a very simple database. It has just one table, and this table contains some fairly sensitive information, at least in two columns. So we have SSN column, which for non-US participants, these are government national IDs that we use in the US, and it stores some salaries of employees, right? So that's the database side. And now I'm wearing a hat of a DBA, right? I just ran this query. I can see all the data with no problem, right? And if I'm an admin on this machine, I have even more techniques to get to this data, right? I could do the memory scan of the SQL Server process. I could generate a dump file and find all that information there in plain text, right? So that's the problem we want to solve. Before we do that, though, I want to show you another part of the demo, which is I have this very simple sample application that basically displays all this employee information. And one little detail that I want to show you here is I have these filtering capabilities, right? So I can filter these employees by salary, and I can filter them by a portion of the social security number. So nothing special, but I want to also call out one important thing. Whenever I use this UI, this application triggers a query, a SQL query against the database. So I want to show you how this query looks like. Okay, let me see if I can open it. All right. So as you can see, this is a fairly simple query, but at the same time, it performs a fairly rich operations. It contains a pattern matching operation, that's the like predicate, right? On the SSN column. It contains the range comparison on the salary column, right? So it performs these rich computations to filter the result set. So what we want to do in this demo, we want to do two things. We want to protect that sensitive data in SSN and salary columns from high privilege but unauthorized users. We don't want the DBA to be able to see that data in plain text. That's one goal. But also, we want to make sure that this application can continue issue these rich queries in the unchanged way. So we don't want to change the application. We want these queries, this particular query, to remain as is and continue to work, right? Despite the fact that SQL Server will have the data encrypted. So let's do that. So normally the first step in configuring always encrypted, you need to provision some keys. I'm skipping that because that's not so interesting. So I have pre-provisioned some cryptographic keys before the demo. So now I'm going to use them, and I'm going to encrypt these two sensitive data columns. And with this version of always encrypted using enclaves, it's a very simple operation that you can issue using SQL, and it completes instantly. Well, it completes instantly for two reasons. First, I have a very small data set, but the more important for this discussion reason is the fact that this operation happens locally, in place, in the local enclave on the server side. So that's one thing. Now, so our data is already encrypted at this point. Let me now do the following. I will rerun this query. So what you see are the results of the previous run before encryption. I'm going to rerun it, and now you can see that if I'm a DBA, right? If I'm an admin, I scan the memory of the SQL Server process. This is what I'm gonna get. I'm gonna get some encrypted blobs for SSN and some encrypted values for salary, right? So we protecting sensitive data in use now. Now let's see what kind of impact, if any, it had on our application, okay? So I will move to our application. Let me actually refresh it. So this still works. So the reason this part works is that the client driver, as I explained to you earlier, it gets encrypted results from the database, but then it transparently decrypts the results and return plain text to the application. The application, as I mentioned earlier, is trusted. It has been configured to have access to these cryptographic keys I've used to encrypt these two columns, right? So that's one thing, and this part is possible even with the current version of Always Encrypted. Now, the new cool thing is that these filtering capabilities still work. So I can filter these employees by salary range and by social security number, despite the fact that these columns, as you saw, are encrypted, right? So now, let's see if queries that the application sent to the database changed in any way, okay? So let's use this monitoring tool that leverages extended events, and let me see if I can open this. So there are two things to note here. So first of all, the query statement is identical as before. It has not changed. And it works still, as you saw, because the application was able to filter, right? The second thing to note is that now the search criteria, the parameters of these queries, are sent to SQL Server in the encrypted form. So they get transparently encrypted on the driver side. The server gets them encrypted, right? So the server has encrypted parameters, encrypted data in these two columns. What it does now is, that you don't see here, it sends the data to the enclave. The enclave safely decrypts the parameters and the data and executes these predicates contained in the query, like and range comparisons, right? So what I achieved here, I protect sensitive data in use while preserving query processing capabilities of the database system. So by the way, this is something that you can try today. Earlier this morning, we announced a public preview of SQL Server on premises, which uses VB as enclave, slightly different technology than what we use in Azure. However, you're gonna see the same in Azure SQL Database in particular. We are in the process of developing and migrating this implementation to Intel SGX, and so that you can take advantage of it in Azure as well. If you want to learn more about this fascinating technology, join me this Thursday. I have a session entirely dedicated to this topic, Thursday, 10:45, confidential computing in SQL using secure enclaves. With that, I'll hand over back to you, Christoph. Thanks.
Thank you so much. To switch back to, oh yeah. So we have one challenge, is my second demoer has not arrived yet. So I apologize to everyone for that. I could give it a try and talk to you about blockchain, but I'm not really the expert, so I wouldn't be doing you a huge favor. Maybe at this point, what I propose is we take your questions, Jacob and I, right? Because it's a topic where we can go pretty deep, and if you guys have questions, I know everyone, some of you are like experts in there, and you probably want to know more than what we covered. Some of you feel like overwhelmed already with all the the content. So let's do this. Let's go through a Q&A, and hopefully Michael will show up. If he does not, then we'll close then. Any questions for? Yes, please.
This is a question about SQL part or general question about Azure Confidential Computing as well?
Do you want to get started with SQL?
Yeah.
Yeah.
So let me make sure I understood and I remember the question correctly. So the question is, how do we transport, how do we send the keys to the enclave, and how can we make the enclave capable of decrypting the data? Is that the question? Okay, where the keys are stored. Right, and okay, sounds good. So the question is, where do we store and how do we manage the keys in always encrypted? So with or without enclaves, keys are never ever stored on the SQL Server side. That's one thing to remember. Now, in SQL always encrypted, we have two types of keys. We have symmetric keys that are used to encrypt data, and we have asymmetric keys, key protectors, right? We call them master keys. So these symmetric keys are stored in SQL Server, but always in the encrypted form. So what I meant to say earlier was that we never store them in plain text in SQL. So they are stored in the encrypted form in SQL. Asymmetric keys, however, the master keys so-called, can be stored anywhere you want. We out of the box provide support for storing them in Azure Key Vault and HSMs, as you mentioned, in Windows Certificate Store, right? Now, with enclaves, key management, maybe not key management, but key usage scenarios become a little bit more complicated. So one thing I told you earlier was that SQL Server doesn't have these keys in plain text, but on the other hand, I told you that the enclave needs to decrypt and encrypt and re-encrypt the data. And the enclave is part of the SQL. So how does the enclave get the keys, right? So the answer to that is that before the first use of the enclave, the client application that has the access to the keys creates a secure connection, a secure tunnel, an equivalent of SSL connection to the enclave through the untrusted SQL Server, and hydrates the enclave with the right keys needed for query processing. Okay? So that's the part of about SQL. I don't know what we can tell in general about key management in ACC.
You covered it. On time. Thank you, Michael.
No problem.
So you have the mic. I'll pass it to you. Michael is going to cover another use case for confidential computing, which is blockchain and the Confidential Consortium Blockchain Framework. It's the official name it goes by.
Yes, so thank you, Christophe. And my name is Michael Galeros. I'm a senior product manager in the Azure Blockchain Engineering team. And we've been very closely partnering and working with the Confidential Compute team because we hear this business problem very frequently from a lot of our blockchain customers around this idea that without confidential compute, without the use of enclaves, there's some very pragmatic challenges that are really blocking much more widespread adoption of blockchain technology, especially in scenarios with a high degree of regulatory requirements or security requirements or at scale. So if we just take your average Ethereum ledger or Corda or Hyperledger Fabric node, and you run it in a Docker or in a VM SKU today, you're going to see these three fundamental challenges. One is scalability. Because blockchain systems, by their very design, it's a computationally intensive exercise to actually achieve consensus across the network. So one problem is you have the physics associated with round tripping across the network. These are peer-to-peer nodes. They have to achieve consensus with one another, so we need to make sure that all agree before the block is committed. This, combined with the computation that's going on the node itself, can really add a lot of friction and latency to the processing and the transaction times. Second is this idea of confidentiality. Well, by its design, most blockchain smart contract systems will write the data in clear and share that across the network. So any participant in the network, whether it's a public network or even a permission network, they would have access by default to the full contents of the ledger. So if you have scenarios where you want a certain degree of openness across the community, however, you still have requirements for point-to-point encrypted message payloads, this becomes very difficult to manage, and typically what we see is customers have to incur lots of expense, lots of complexity in terms of key management and crypto, and there's some novel, very complex things like zero-knowledge proofs and homomorphic encryption that's kind of making its way through, but it's very difficult, it's very challenging and complex to implement. And then finally, the idea of governance. So if I have these counterparties that are coming in, they're just standing up these blockchain nodes and connecting them, what's the SLA? What's the commitment between the counterparties? What if somebody is behaving maliciously and trying to game the system? Can I kick them off the network? You know, these things become programmatically very difficult to achieve if I don't have some framework that ties it together. So what we're able to do, taking advantage of confidential compute, is this idea of the Confidential Consortium Blockchain Framework. Previously, you might have heard of COCO Framework. This is kind of now the more official name, if you will, going to market. The idea is we have this open source framework that, through an architecture we're going to look at here momentarily, will allow all of these counterparties to come together and achieve much greater transactional throughput, much more reliable security by virtue of the fact that we'll have key management structures and certificate identification structures that will go out to each of these nodes, each of these participants. So then the idea being, if I'm a new participant coming into the network, there's some cryptographic primitives I'm going to be expected to contribute to the CCBF to authenticate and authorize my node before it'll start trading on the network. And then finally, the idea then of these enclaves supporting a wider array of consensus mechanisms. So I'm no longer bound to just say proof of work or the standard default, Byzantine fault tolerance consensus mechanisms that the ledgers impose upon me. Instead, I can do more of a standards, Paxos-based or much more highly scalable, familiarized, distributed computational algorithm to get that consensus across the network. So architecturally speaking, again, it's based on the core principles that you saw earlier about the enclave and the confidential compute. Basically, we have on the left there, you can have your administrator, you can have your distributed applications, your smart contract applications. The idea is that these process through this CCBF interface that sits on the validating node. That then interacts with this enclave. So you imagine this is your, perhaps through your SDK, or your SGX SDK for smart contract. That then sits in front of three distinct structures. You have your state of affairs relative to the consortium, relative to the network. You have your blockchain core, and so what we envision is this will be the blockchain protocol of your choice. So if you want to run Ethereum here, you want to run Hyperledger Fabric or Corda with the adapter that then syncs it into the larger CCBF. And then finally, to give us that hyperscale throughput, you're going to have this replicated persistent store. So you'll have a typical, familiar SQL, NoSQL type structure there at the back end to cache these transactions, to expedite the throughput, and really give you kind of that hyperscale performance experience for those workloads that maybe would otherwise adopt blockchain were it not for the long processing times associated with achieving consensus. So if we look at Ethereum specifically for the moment, what we envision is that using the enclaves, we're going to have this ability to put the ledger and the smart contract execution in an appropriate access control model. So the idea is make things available via API and smart contract that are okay to run in the clear, yet when we get into the actual data itself that might only be authorized for certain counterparties in the trading network, those things should live in the enclave, where in order to access that information, you're going to be challenged for keys, and you're going to have to be able to present your node's keys to be able to see and reveal that data. Being able to actually disable access at the block level. So again, as you think about the blockchain, it's the sequence of transactions that's happening, and right now it's kind of an all or nothing deal typically, where you've got the entire sequence being shared across the network, and as each network copies that transactional ledger, you're going to have access to the whole thing. Well, what this framework allows is maybe certain blocks in there are redacted from certain counterparties. So you might imagine that you'll see a sequence of transactions that are available for the whole network, yet then a block of ciphertext for only those parties who are not authorized to be able to reveal the transaction. And then finally, having this verification of the caller, because again, blockchain is fundamentally a peer-to-peer network. So I need to be able to authenticate and authorize who it was that actually invoked the smart contract. So today, again, it's basically an all or nothing deal. Anybody who's on that network, again, whether it's permissioned or private, is able to, as long as they know the address of the smart contract, they call it, they place the transaction, everybody gets a result once consensus completes. With the CCBF, the idea now is every node is authenticating and authorizing per transaction. So now, before the node attempts to use a transaction, I can interrogate that node, I can confirm they're authenticated and authorized to perform that operation, and then simultaneously I can follow that through to the data payload level as well. So that's all we have there from the CCBF perspective. Any
Well, I think we should take questions.
questions would be great. Anybody have any questions on? Yes.
How much data can you fit into the TEE environment based on the current technology that's out there?
Well, I mean, just purely on blockchain, there's not necessarily a limitation other than the amount of storage key, storage allocation you've set aside. I mean, it's elastic, so you're going to, so there's not necessarily a limitation other than just continuing to grow at scale. From enclaves and from TEE.
So as far as I know, SGX enclaves, they have some pretty low limit as the size of the memory in the order of a few hundred of megabytes, but I don't recall the exact number.
It was 128, but that was, I think it's 128. I might be wrong because we're releasing the VM in a few days. I know we might have improved the service in the last few minutes, but I think it was 128 megs. So fairly small, right? And that's why I was mentioning it needs to be a conscious effort in your development cycle. So I'll try to put that back.
And also, too, there's some reference material up here as well that you can certainly photograph and take with and research as well.
Right, but it needs to be that conscious effort of what is it you're going to put in the enclave, what is it you're going to put outside of the enclave, right? Because the enclave is fairly small, so you cannot put everything in there, right? So as you approach the application building, you need to really think of okay, this piece of data, this piece of code needs to be in the enclave. This can afford not to be in the enclave, right? And today, that is the challenge of building for ACC is how do you strategize for that, right?
Go in the back first. Well, I think that as with anything, again, purely from the blockchain perspective, and then TEE can comment, I think it starts with good risk fundamentals, right? So I think that right now, a lot of the primitives we've seen around sort of the SGX SDK is you'll see better access restrictions and flow control integrity control structures around the enclave itself, but maybe not so much the SDK. So I think the trick is you have to risk assess each step along the way and each input and output into it, and really test, prove, experiment before you kind of go any further for a spectrum style attack. I don't know when it's.
Yeah, no. So we learn a lot from these kind of events, right? And I think it's a virtuous cycle of learning and fixing and learning and fixing, right? I think no system is ever proof totally untemperable, right? And but with ACC, when the data is encrypted in storage, in transit, and in use, it gets really hard, right? I mean, if you think about this, it gets really, really hard to try attack data or get access to data, and even if you get access to data, it's encrypted, right? So I don't have specific comments about these two events, right? But I think this is happening. This is going to happen again, right? But the whole industry is improving and really limiting the window of what is it that you could do next to go and attack a system, right? We had another yes, please, sir. I think so, right?
I wouldn't see why not. I mean,
Yeah,
basically, if you're deploying the SKU that has the XGX enabled, and then you just deploy the container on top of that SKU, I mean, as long as whatever code you're running is running within that enclave, it should be able to. Now, in terms of that's bound to have interfaces on the registry or the control plane for that container, you may have some additional authentication and authorization work to do. But theoretically, it should at least work, and it should definitely offer an improvement to security.
Want to take that one? Yeah.
Right, so there is a question about when the always encrypted technology with enclaves are described, which are the flavors of Azure SQL database or SQL in Azure in general that's going to be supported in. So first of all, I want to repeat and emphasize at this point that publicly what is available today is not in Azure. As of today, you can use SQL Server and install it in your on-prem environment. However, we are on path to enable it in Azure, and our goal is to make sure that this feature is available in all the flavors of SQL in Azure, including Elastic Pulse likely and a SQL in a VM. I don't have a specific timeline for that, but that's what we're going to work on very hard after we very close to completing this work in SQL Server on-prem.
Yeah, I was like, say it's about perspective, not about roadmap.
Yeah, sure. So there's a question: how about protecting the data on the client side? Or I guess we could expand your question and ask, if we envision an application to be a distributed application that uses different services in Azure, perhaps, like some of it may be hosted in Azure websites, or there are web components that you're hosting in Azure. Why don't protect that data as well? I mean, that's the nirvana kind of ideal vision we heading towards. We are doing some effort in that direction with multi-party machine learning, which kind of solves similar problems. So yeah, that could be the next logical step. We don't have a timeline for that yet, but again, there is no technical reason why that should not be possible.
In the blockchain world, you're starting to see this idea of like hardware wallets gaining a little bit of traction, and this marriage between the client. If we think of the wallet as the client, classic client application, and then being able to actually use that as the basis to transact with the web distributed app or even the ledger directly. So I think it's coming. I think it's just early days, and I think that developments like confidential compute, like having readily available VM SKUs with the enclave technology accessible for experimentation and prototyping and further development is only going to expedite and get us closer to client-side enclaving.
I think that's my point of closing word, right? It's very early innovative technology, right? We're just releasing this. Our hardware partners, they're just working on improving the technology every day. Someone had a question about the size, and I was like struggling to answer because that changes almost daily, right? We're very excited with the launch of the SDK because that gets this technology in the hands of like millions of developers, right? That can come with very smart ideas like you had, right? And we'll build over time what's the ecosystem for confidential computing. But if you think about this, if you have that data encrypted in transit, in storage, and in use, that's sort of like the holy grail of how we make the cloud super secure for everyone to use, and everyone to use whatever they need to use the cloud for, and not have this struggle of like, well, that thing is my key data, or it's my key code. Can I really trust the cloud with this, right? And that's the barrier we're trying to breach, is that developers and companies can bring data and code to the cloud in full trust. And I think we're in the early days of that, but that is going to change the way people consume cloud, we think, and why we're all super excited with this. And you have to leave again? The guy is a rock star. It's like, he has like one session every 10 minutes. Thank you, Michael. So we'll close here. I think we don't have any more slides. The next one is, if you want to take a picture of this one, it has some like interesting links. Nothing's better than like taking a picture of a link and go back and typing the link in a browser. But that's secure, right, at least? Yeah, that was the last slide. So thank you. We'll take questions as you have them, because I saw a few hands that were raised and didn't get an opportunity to answer your questions. I don't see any more. Well, thank you all. Thank you for your time the last slot of the day. Thanks.